right. Hello, everybody. I'm Brian Sam-Bodden, and first of all, smile. All right. So, whoa. I'm here to talk about RubyMotion, and I titled this TDDing iOS apps for fun and profit with RubyMotion. The profit part hasn't arrived yet. I'm working on that, but I'm having a lot of fun with it. So let me tell you a little bit about me. I'm not from Portland, actually. This is awesome to be the last session of the conference. I hope you enjoy the conference. I had a great time, and I hope to see you next year. So I am a long-time programmer. I've gone through pretty much every language you can think of. Started with Lisp. That lasted about 3 months when we ran out of money, and ended up doing Java for a long time. And in 2005, I made DHH here at OSCON. And I was talking about a clone of Rails, and he promptly made fun of me. And fast forward a year later, I was running my own Rails company. So what do you know? I live in Phoenix. I'm not in the witness protection program, which seems to be the tendency in Phoenix. And I want to start with confessions. I'm an Apple fanboy. There should be no reason a 41-year-old man has a white leather case iPhone. There's a price to pay, but you know, I've been paying it willingly. I work with Ruby every day. We're a Rails consultancy. We do TDD-driven development for our clients, agile, the whole shebang. And before that, I used to do, back in the 90s, desktop applications. Borland's Delphi, you guys remember that? You remember 4GLs? So I really wanted to do iPhone and iPad applications. But Apple wants you to use XCode. And XCode took me back in time to those Delphi and Visual Basic days. And it felt pretty retro. And I tried it, but I just could not get myself to go back to that mode of operation, basically dragging and clicking and connecting things with drop-downs. It just didn't feel right. It felt like this. It felt like a pretty complex environment where there was no flow. You had to live in it for a long, long time to have that sense of flow. And everything about it just slowed me down. Trying to do simple things resulted typically in me actually restarting the application from the ground up. And then there's Objective-C. I know there's a lot of people that really like the language, but for me, I've done C and C++. In Java, it felt like a weird combination of some good things that turned out pretty bad, like Rosemary's Baby version of a programming language. So I tried it, couldn't do it. Then I heard that there was something out there called RubyMotion. Actually, let me rewind a little bit. I found Mac Ruby because I wanted to do beautiful apps on the desktop for the Mac. So I started playing with Mac Ruby, which is a Ruby interpreter for the Mac, built on Objective-C. But luckily, somebody else had to do that work, not me. But there are a lot of constraints that iOS has that would not allow you to build an iOS app with Mac Ruby. So somebody created RubyMotion, which is you can think of it as a fork of Mac Ruby dealing with the restrictions that iOS imposes on the environment. RubyMotion, it's a commercial product, but it's actually pretty cheap. It's $199. And if you stick with me till the end of the session, I'll give you a surprise slide at the end. The source is available, but not all of it. There's some parts of it that are hidden from the public. But there's contributors, there's contribution being done to RubyMotion in the open source fashion. So there's a lot of gems appearing. There's a lot of DSLs appearing to basically help us deal with the sometimes complexity that is iOS development. So they title it a Ruby-based toolchain for iOS. And it is based on Mac Ruby, but targets iOS. It compiles, it creates binary artifacts that you can send to the App Store and sell them and make a lot of money and start driving race cars and stuff like that. It was created by Lawrence Sansonetti, and I'm probably mispronouncing his name, but I'm sure he'll be okay with it. He worked at Apple for 7 years and worked on iLife and OS X. So the guy had a lot of experience with the environment, but he also was a Rubyist on the side. So Mac Ruby came out of his effort and a few other people. But one of his gripes was this, that XCode was just not a really good environment to deal with Mac Ruby. Even when I was playing with Mac Ruby, I was using TextMate or Vim. So the guy doesn't like Xcode. I tried it. I don't like it either. It's actually pretty to look at. It looks complex, and it makes you feel like, whoa, this is pretty nice. But after a couple hours struggling with it, it just didn't do it for me. So who is RubyMotion's target audience? It's us, really. If you are an expert Xcode, Objective-C, iOS developer, you're going to probably laugh at RubyMotion because it's in a language that you don't understand, following processes that you're not used to. One of the things that I started doing when I started playing with iOS is trying to figure out how they did their test-driven development. And they don't. Actually, they barely test. It seems that testing is, they probably could buy that robot that they showed at the, Lightning Talks yesterday, because it seems that it's just user testing and throw it over the fence and good luck, the old QA department type of approach. And I can't work that way anymore. It's been too long to actually go back to those habits. So RubyMotion is targeted to Rubyists that might not know iOS at all. And that was me. I started learning the iOS APIs through the veneer of RubyMotion's Ruby flavor. Web developers should feel pretty comfortable with RubyMotion because it gives you a Rails style of development. You're going to see that we have models, views, and controllers. There are gems that provide APIs to make each one of those areas of the MVC stack more palatable to you. And you can use a shell. You can use Bash. You can use whatever shell you like to use and have that semblance of writing a test, failing the test, passing the test, and moving along your design and development process that way. So TDD and BDD are good friends to RubyMotion. It's not as fluid and agile as, let's say, a Rails application nowadays, because we've evolved this stuff over the years, but it's getting there. And my goal for this session was to prove to myself that I could TDD a RubyMotion app. So let's jump a little bit off track for a second. An obvious question that always comes up is, why wouldn't you just build a web application? And it seems that users are still getting this tactile responsiveness feeling from native applications that they don't seem to get from HTML5 web apps. I'm not going to spend too much time on this, but I left you a couple graphs in there that you can take a look at. I think that to hit market, it's pretty good to have an HTML5 application, and learn how your users use your application, and eventually you might actually want to target a native application if your domain requires it. So if you're doing gaming, if you're using any of the hardware devices on the phone, you probably want to go native. So let's do our first example, which is our hello world in French. I hope that's right. Lauren's going to kill me. And I'm going to show you just a quick slide that RubyMotion, it's all encapsulated in the motion command. In the motion command, it's like the Rails command. You use it to create your applications. In this simple example, I'm creating a hello world application. And it's also rake-driven development. So you have as you create a RubyMotion application, you have a set of rake tasks that can allow you to do a lot of different things about your application. You can build it for a specific device version, you can build it for the simulator, and you can run your test. In most cases, you're going to use rake to run the application and see it live, and rake spec to actually run your test. And that's typically the two commands that I use all day as I'm building iOS apps. So I have a cheat sheet for my demo. and I have the simulator right on screen. So first thing I'm going to do is show you the version of RubyMotion that I'm running. And let's create our first RubyMotion application. And if I run the rake command, it's rapidly going to fail because I'm not in the directory of my application. This is that moment as a presenter where you're like, cold sweat, CD to the directory. This application does nothing. But as you can see, it launched the application on the simulator. If I exit out of the application, you can see that there's the icon created for the app. The only problem is that it doesn't even have a single view, so all you get is a blank screen. Now, one thing that I wanted to mention, let me run it one more time, and notice that my console now is sitting at a prompt. So that's the REPL. That's the REPL of RubyMotion, which is like the IRB or the Rails console. And that is the place, that was my experimental lab to learn about iOS. Because, you know, what's the number one method that you call on a class that you don't know? Methods. So typically, I started digging into the iOS APIs through the console and playing with things. And the nice thing is that whatever you do on that console reflects live on the simulator. So let me take some of my CAN examples that I have in here and show you what's going on in here. So the first thing that you notice is that the self object, it's main, just like in many interpreters. I'm going to create something called an alert. And an alert, it's the UI alert view. It's one of the iOS classes that we use to basically do a pop-up dialog. And I'm going to set some values on my alert. Let's put a title, a message, and now I can go ahead and show my alert. So, and that's the cool thing about it. Yay, one dialog on an iPhone app, awesome. But I know it looks simplistic, but having that feedback loop, it's what allowed me to actually learn iOS. I mean, I'm not an expert by any stretch of the imagination, but it has allowed me to delve into something that looked really foreign to me before and really extract some knowledge out of it. I can also dismiss that alert. So it's a pretty simple environment to learn about iOS. And if you're a Ruby developer and you've been wanting to learn about iOS, to me, this is the best vehicle that you could possibly find. And it's only 99 bucks. So. Now let me go back to the slides for a second. So again, that's my number one reason to love RubyMotion. It's the REPL, the console. Allows you to explore the RubyMotion API and therefore the iOS APIs. RubyMotion basically puts just like JRuby and MacRuby and any other foreign platform Ruby interpreter, they create a thin wrapper around all of the classes available in iOS. So the REPL to me was the first thing that brought me into the platform. You can interact with the running iOS application and learn and discover. And actually, we made it past this. Yay! So now let me tell you about reason number 2 I like RubyMotion, and that's the bacon. Who doesn't like bacon? Bacon, it's an RSpec clone. And in particular, RubyMotion uses something called Mac bacon, which is very expensive bacon. And Mac bacon, again, it's a small clone of RSpec, not completely one-to-one syntax-wise with RSpec, but it's the vehicle that we're going to use to do BDD and TDD with RubyMotion. Here's a little slice of Mac bacon, and you can see that you have a describe block. You have a string that describes the context of the block. Then you have before blocks like you do in most BDD frameworks like RSpec. And then you have your it examples. So for example, an array, it should be empty, it should not include 1, things of that sort. You have more of this fluid method chaining API that in RSpec now we have the spec parenthesis in some statement. So it's slightly different. It's probably closer to RSpec 1.0 than 2.0. And it has a lot of different things that allow you to basically do the type of testing that we're used to doing in the Ruby and Rails world. So RubyMotion TDD. The highlights of the demo that we're going to see. First of all, testing, it's all done with Bacon. Red-green refactor looping for iOS. Sometimes not as easy as it sounds. The environment for RubyMotion, it's meant to test units. So you're meant to test, for example, one controller. Your largest unit that you can test is a controller. So it's meant to test one controller in isolation. If you're testing going from one controller to another one, you have to go with something outside of RubyMotion, something more akin Cucumber. And there's a few products out there that are Cucumber-like specs to basically run full RubyMotion suites or iOS suites in general. And I'm using 2 libraries just to show you that here's where the power of Ruby, open source, and our community comes in to basically save the bacon. Motion Model, it's an active record-like clone for iOS applications that uses one of the simple local storage facilities that iOS has. And Form Motion, it's, imagine simple form for iOS. I'm a pretty lazy developer, so I wanted to find ways to declare a model and then say, turn this into a form that somebody can input data in the phone app. So I'm using those 2 libraries in combination just for the demo. There are probably by now hundreds. There's a whole list of libraries available out there, gems available to you. And they cover everything from 2D gaming to dealing with some of the hardware devices on the phone, all kinds of stuff out there. So let's look at our second demo. And I have an application that it has probably around 40 or 45 commits. The last time I tried to demo the whole thing, it took me 2 hours. So I'm going to do some of the initial commits and then fast forward in time to some of the last commits so you can see the progress that I made in there. And my application is called Okonawa, which according to Google Translate means done. But I don't know if it's done as in being completed with a task or done as in a steak. So it could be a complete misnomer of my application, but we'll see. I should have asked Joko before she left. And the application, it's on GitHub, so you can, if you get a copy of RubyMotion, you can grab it and play with it. And this is what it looks like, but let's get to the demo first. All right. So I'm using a Git presenter so I can fast forward through my commits. And if you can see there, I have a pretty large list of commits. So I'm going to notice that the initial commit, by default, a new RubyMotion application. Let me show you what it has. It has pretty much nothing. It has an application delegate, which happens to be your entry point into the iOS stack. And from there, you basically wire your controllers and your views and your models to show something to the user. So by default, they have nothing. And in terms of test, it has only one test that says that you should have a window. Let me make that a little bigger. So if I run those tests, you will see that I have a failed test. And I think Laurent intended for people to basically start at the red state of the TDD cycle and then start building, fleshing out the application that way. But most of the examples that I found out there, it's like people are following the iOS mantra and not testing or testing after the fact. And if you have an environment as powerful as Ruby and Rails when it comes to TDDing an application or close enough, I think you should use it. So now let me move forward to my first passing test. And my first passing test just says that I should have a window. So I'm trying to pass the test that was broken that comes built in with RubyMotion. And to do that, now I just slapped a window inside of that delegate. And you can see that there are some syntactic things that might look foreign to a Rubyist. For example, that word alloc, that means allocate, or you guys remember malloc from C and C++. So in here, there's a concept of allocating memory for something. Luckily for us, in most cases, you can replace that with new, and it seems to work just fine. So in here, I'm creating an instance variable called window, and I am initializing that with the current frame to basically take the whole bounds of the screen. And if I were to run my application now, you will see that it's still a blank screen, but it happens to have one window. It's just blank. All right, so going back to the commits, now I'm going to fast forward. So this is a to-do application. I was setting out to build a very simple list of to-dos that had a due date and a Boolean that will tell me whether the to-do was accomplished or not. So I'm going to fast forward now to my first failing test for real functionality, which is commit number 5, which is it should display the given to-dos. So let's go to number 5. Run my test, and I should see the test failing. Ignore the stack trace. So I have my to-dos controller. Typically, one of the things with TDD that it's hard for people jumping into TDD, it's where to start. And sometimes you try to start with something way too complex. So with iOS, with RubyMotion development, the first thing that I said to myself, I'm going to test something very simple. I'm going to test like the controller class that I meant to create, it's not there. And that gives me just a place to start. It might be a silly test, but it gets you started. It gets you down the road of basically doing the TDD loop. So typically, I add a test like that that says the to-dos controller should exist. As you can see, the original application test that should have one window, it's passing now. But my display the given to-dos test is failing. All right, so now let's fast forward to the next commit where I actually implement the minimal thing that would pass that test. And for that, the process of getting to that first real commit, I actually use the console to figure out, hey, how do I show a table of data on an iOS application? And there happens to be something called a UI table view, and that's where I basically started playing with. So it's a typical discovery process, going to the APIs. The API exploration happens through the console, see what methods are available, try them, see some memory errors because you don't know what you're doing, and eventually flesh it out to the point that it makes sense. So let me show you the code to pass that. And I'm going to make it just slightly smaller so we can see the whole thing in one shot. So what I did, I have my window as before, and then I'm creating a table, which is a UI table view. My table view, it's also taking the whole screen width in height. And then I created a very simple array of things that I should buy for my pantry. And I'm creating something called a data source, which is down below. In my data source, it's an object that the table view is going to use to acquire its data to ask, for example, how many elements are there on the table and things of that sort. So notice that I'm implementing two methods in here. Table view, number of rows in section, and table view cell for row at index path. And this is a good stopping point to talk about the weird syntax that you're seeing right now. First of all, notice that there's a lot of camel case rather than snake case like we're used to in Ruby. Some of these methods are direct translations of the Objective-C signature. Objective-C has a concept of pseudo name parameters, which Ruby 2.0 would have name parameters. But in this case, that self for row at index path, colon index path, it's one of those name parameters. So for most people, it looks like you're overriding the same method down below. It's a completely different method signature. And the RubyMotion interpreter understands that. It took me a while to not thinking that I was overwriting my own code in the next line. So notice in here that my to-do data store has a data attribute, and then inside of the table view self for row at index path, that's the question that the table will ask when it says, hey, I need some data for this row. I return something called a UI table view cell. So again, this is all discovery of mine through the console to get to that point. And let me run the test now, just to show you where we're at. So now we have a clean passing set of specs. If we run the application, it's not terribly exciting right now, but I have a table of data. And believe me, when I got to this point, I was like, yes! I have built an iOS application. I am the master of my domain. Give me a couple weeks, I'll be rich. Now, one of the things that I wanted to show you, let me go ahead and delete the applications that I have on the simulator. One of the things that I really like about this, it's that if I run the test, what RubyMotion does, whoa, what is that? What RubyMotion does, it's actually run the tests and creates an application that has the state of those tests at that point in time. So I could run this application again, and it's running the test. It's just one, so it's really fast. But if you have a pretty comprehensive suite of tests, when you click that application, and you could save that application, you can have snapshots of it if you want to have a binary of what the tests did at a specific point in time. It's a produced artifact of your test suite. And I thought that was pretty cool because as I'm building the application, I would play that, and it's kind of like seeing a capybara a suite running through a website. You start seeing like, oh, okay, it kind of clarifies your mind of the path of behavior that you have in your application. All right. So now that you've seen basically what the TDD cycle of doing things in iOS with RubyMotion looks like, let me fast forward to some of the end commits. I'm going to show you first what I did with FormMotion. So let's go to commit number 26. And again, let me run the test. Unfortunately, things get compiled. So we're talking about now C, object linking and embedding and all that stuff that we tend to forget about when we're using Ruby. But it's happening all in here. So notice in here that now I have fleshed out my test suite to be a little more complete. So now I have a to-do controller. I have a model now. My model, notice that I started with the simplest possible failure. Hey, I want the model to exist in the first place. And I'm checking that it has a name, description, due date. Now I'm checking also that I have a to-dos controller that should exist. It shows all the given to-dos and also shows the correct label for a given to-do. Let me quickly show you what that test looks like, because I heard clapping, and that means that my time is up. Unless it's just some random guy out there that's just really good. So here's my to-do spec. And this is really the spec for a very simple model object. And here is my extended to-dos controller spec. So let me run this so you can see what we have so far, and then I'll really quickly move to the last commit so you see where I ended with this. So here's the application. Notice that now I started learning things about iOS by some of the warning messages that appear in the console. Like, for example, a view should not be unrooted from a controller. A view needs to live inside of a controller. And I learned all that through the warning messages in the console. Even though I have pretty much every iOS book that has been in print, I think I probably read snippets of each one of those, but this was the best environment for me to learn this stuff. So now I have a model, a real model, with local storage that backs every one of my to-dos. I use a form motion to create a one-liner form to basically be shown in here. And as you can see, I can there's no such thing as fat-free orange juice, isn't it? But as you can see, the label doesn't change, and I'm not saving anything. So let me now fast forward to my last commit, and I'll show you where I ended. All right, 34. So there's 34 commits in there. It's been a lot of fun actually building this example for the presentation, because even the things that I thought I knew so far were clarified. So here's the final specification set. And it's coming, and it's coming. The only problem with RubyMotion in demonstrations is that compiling time will get to you. So now I have a slightly more complex testing suite, and you can see that stuff was happening in there. Now let me run it. And you should see the final version of my Okinawa application. Notice that I added some decorations in here. There's a create new to do button now. So a little more complete than before. When I save, my new to do, I put them at the bottom. I should probably put them at the top. If I modify an existing to do, oh, what happened? I broke it. Save. Yeah, I had a listener in there that apparently I broke, but well, that's what happens when you do live coding. So, but again, iOS, it's no longer a frontier that's too far for a Rubyist to travel to. I feel pretty comfortable with the environment now. The syntax, it's not very hard to grasp. The moment that you stumble upon a class that you don't understand, there's a lot of examples written in Objective-C that now my mind is translating directly to RubyMotion after just a few months of working with RubyMotion. So it is a pretty viable avenue for us to actually build cool iOS apps. Let me show you a couple of the things that are out there now. There's a bunch of wrappers for everything that you can possibly need for RubyMotion in iOS development. And Basecamp for the iPhone, it's built on RubyMotion. And it's partially some web Rails app and a RubyMotion app living together in harmony. And there's a bunch of other stuff out there. I mean, there's iTunes-like apps. This is one for the London subway. Just figure out where you're going and what times the trains are arriving. So people are building beautiful applications. I didn't have the time to put some makeup on my pig, but that will be probably the next step I'll take. Send me an email, and Lauren will give you a 15% discount on RubyMotion. So do the math, about 14 bucks. And all the sample code, it's on my GitHub repository. And I'm actually going to put an ebook together about this experience as I flesh out about 3 or 4 applications with RubyMotion of different kinds and types and flavors, including games. So, any questions? All right. Well, thank you very much, guys.